I'm Meghamala, Working Assistant Professor from Electronics and Communication Department, Institute of Aeronautical Engineering. And today, I'm going to discuss something about tasks and functions. Okay, so let's see what are the tasks and functions in the Verilog. So before going for the functions, let's discuss what are the tasks. Okay, in general, we know the task is nothing but it is something, it is like a job, right? A particular task, as a human being, there are many tasks to be accomplished in our day-to-day life. So task is nothing but a job. Okay, a job to be performed, or else it's a part of it's a work. Okay, a task is nothing but it's a kind of work where we need to complete it, right? So coming to the task in the Verilog. Okay, in the Verilog, task is declared within a module. Okay, so we know that module is a keyword. So tasks are mentioned, or else they are declared within the module, and they may be referenced only from within a cycle or single pass behavior. So here, if you observe, we are saying that tasks are they meant only inside the module, right? So inside the module, and also maybe they are referenced from the within a cycle or single pass behavior, or else, as we said that it is to be mentioned or is declared within the module, so that we are saying that it is from the within the circle. Okay, then a task can have some parameters which are passed to it, and as a result of executing the task can pass back to the environment. So a task can have some parameters. Yes, obviously a task to perform some job, we need some parameters, right? So the parameters are, they have to pass to it through the task, and the result which are executing from it can be obtained, or else can be retrieved. Okay, it can be retrieved back. Then when a task is called, what happens is, when a task is called, the copies of the parameters in the environment are associated with the inputs, outputs, and inouts with the task. Okay, according to the order in which the inputs, outputs, inouts are declared. So here, as we are saying that tasks are meant to be declared inside the module. So as they are declared inside the module, such that we can see that there are different copies of parameters, right? So here, when the task is called, okay, when some particular task is to be called, then the parameters are to be copied from the environment, and those parameters, they could be in terms of input, output, and as well as the in out. Okay, the declaration, they can be declared input, output, and as well as the in out. Then a task must be named. The name, we can give the name for the task, for the different tasks, and they may include the declaration of any number of combinations. Okay, so here we can give the name for a particular task, so that they can what are we saying, they can include the declarations. Okay, so as we are giving the name for the task, so that we can include, or else we can declare different parameters, the names of such parameters, and the parameters can include input, output, in out, register, integer, real time, and also the event. Then the variable type, real time, and real time are additional members of the registers register family of types. So here we are saying that the different parameters, they could be in terms of input, output, in outputs, and also the registers. So here we have mentioned, right, real time and also the real time. So these are nothing but the additional parameters. Then a task must be specifically called with a statement. So how we are saying that a task, we are saying that task is to be mentioned inside the module. So how the task are to be called is, we can call the task with the statement. Along with the statement, we can call the task, and it cannot be used within the expressions as a function. So we can call in between the statements, but we cannot give, or else we cannot name it as a expression, or we cannot name it. Okay, we cannot name it within the expression. That means what? For example, a is equals to b dot x, right? So within the expression, we cannot introduce a task. Okay, we cannot introduce a task, but whereas we can give the name of that task. And here we have a syntax with respect to this task. So the syntax goes like this. A syntax begins with the keyword task. In the Verilog, the very good thing that we find is whatever the perform, or else what are the task or the functions or the parameters or the switches and also the gates, whatever you're considering, mention that we need to mention with the keyword, right? And that keyword is nothing but the name of itself, the name of the parameters that you are considering. So here, as we are discussing the task as a main theme, then the keywords goes with the task. Keywords goes with the task itself. Okay, right? And also in the switch level parameters, in the switch level modeling, we have seen different types of switches, right? For example, for NMOS switch, when you're writing the code, in the code, we are mentioning the keyword as NMOS, right? So this is how the keywords are, the declaring of keywords is very important in every aspects in the Verilog. So here, coming to the task, you have to start with a keyword called task and end the keyword with the end task. So, for example, we are starting with the module, right? When you are starting with the module, your code with the module, then obviously we are ending up the the code with a keyword called end module. If you are starting your code with the begin, then you have to end with the terminate the code with the end. Okay. So likewise, we have two keywords pertaining to this task. The task, the initial keyword when we need to mention is a task, and in the final, when you're terminating, you are mentioning it as a end task. Then inputs and outputs are declared after the keyword task. So obviously after the module, in the port list, we are mentioning the input and as well as the output. So here, in order to declare this task, there are two styles to perform. In the two styles, we can write a code. One is style 1 and the other one is style 2. So the style 1 is task name, input port list, in out and as well as the output. So here, the task is a keyword, and name is the name of a particular module that you are considering, and then the declaration of input and as well as the output. So this is a declaration of input and as well as the output. And then I'm beginning, and then followed after the begin, we'll go with the statements, right? So as soon after the statements declaration, then we are ending up with the begin, you are started and then you are ending, and then finally end task. So this is a one way of writing your code regarding the task, and the other way of writing your code regarding the task says like this: task name, and this is the port list. So in the port list, we are mentioning separately the inputs. For example, my inputs are A comma B. Okay, then my in out ports are Z comma Y, and my output ports are P comma Q. So in the port list itself, we are separately declaring all the inputs, outputs and in-outs ports, right? So this is one way of declaring the or else writing the task, and then followed with the begin, statements, end, and then end task. So in the two way, the style 1 or style 2, in the two way, in these two styles, either 1 or 2 we can go for. Okay, but the thing is, you have to remember that when you're writing your code, your first and foremost keyword should start with a keyword called task. And then finally, when you're terminating your code, remember that you have to terminate it with the end task. That is a important thing. Then a keyword automatic will make re-entrant task, otherwise it will be static by default. So here in the task, we have the static and the as well as the dynamic tasks, right? Static and the dynamic start. When it comes to the tasks, when it comes to the static task, remember that the keywords are different. Okay, for this static tasks, so the keyword automatic will be the re-entrant task. Okay, otherwise it will be static by default. So if you are writing your code either in terms of dynamic or static, remember that if in any case, if you are writing your code in terms of this automatic keyword, it will make the re-entrant task. If you find anywhere these two such kind of keywords, then yours says that particular task is going to be in a static position. Okay, static by default. Then if a task is static, what happens is, if a task is static, okay, if a task is static, it means that all its member variables will be shared across different invocations of the same task that has been launched concurrently. So what happens if your task is in the static medium, It means that all the member variables which are pertaining to the parameters, all the parameters with respect to the variables, what happens is the variables will be shared among the different invocations of the same task. What happens is, for example, this is a task 1. This is a task 2, right? So in the task 1, what am I doing is, I'm going to perform the multiplexer, right? So for this multiplexer, I can go 0, 0, 0, 1, 1, 0 and 1, 1. Okay, based on the selection lines, I'm going to obtain the output, right? So what happens is, sometimes I'm giving the variable, my inputs are A, B and selection lines, and my outputs are Y, right? This is the multiplexer. What happens is, if your task is static, then here the variables, okay, these are the variables or the parameters pertaining to the input and output. What happens is, they will be shared among all the different invocations inside the task itself. Okay, that means what we can see some chaos. Okay, we can see some chaos between all the different tasks. Okay, all the different between the modules, parameters modules, and then so they can be launched concurrently. That means what, concurrently we can see some changes been occurring inside the module, or else inside the tasks. Okay, so different invocations of the same task, inside the same task we will see some changes will be occurred concurrently. This is nothing but because of this automatic, and that will make the re-entrant task. Okay, then we can see how we will see that what is a calling a task. Calling a task, it means that if a task does not need any argument, then the list of arguments can be avoided. So obviously the sentence says that if you are not or else if you don't need any task, okay, if the task does not need any arguments, if you don't want any arguments, then what happens is, the list of arguments can be avoided. If you need some arguments, then you can consider from it. But if you are not needed any kind of argument, then what happens is, you can ignore the list of arguments. You can be avoided it. And if the task needs arguments, for example, first statement is, if you don't need task arguments, then what happens is, we can just avoid it, right? But if you need the if the task need arguments, then they can be provided in the same statement as its invocation. So if you need any arguments, the arguments are available inside the task. They can be provided. Okay, the arguments can be provided in the same statements itself. Okay, that is how we can call the task. We can call the task based on the arguments. If you are needed arguments, then you have to call it from the same statement. If you don't need arguments, it means that the arguments are not the arguments are just avoided. Then, so here for this also we have there's a code with the style 1 and style 2, as we have seen in the previous one, style 1 and style 2. So this is a style 1. Here we have some arguments, right? So see, style 1, task sum. So what we are doing is, we are just summing up 2 bits. Okay, the output is C, A and B are the inputs. Output is C. So task sum, input 7:0, AB, output 7:0, C. And begin, what is a main task, is just to sum up the 2 bits, right? So C is equals to A plus B, and then end task. So this is one way of writing your code in terms of task, okay, with respect to the arguments given. And then this is another way of writing your code. It's a style 2. In the style 2, how can we write the code is, task sum. Our main thing is, we are just summing up the 2 input bits, right? So task sum, then input is 7:0 A and B, and the output is 7:0 C. And now we are begin. What are we begin? We are saying that statement is all about the continuous assignment statement, saying that C is equals to A plus B, declared properly. Then end task, and then after that, what are we doing is, we have the initial begin. In the initial begin, the reg 7:0 XYZ, sum XYZ, end, and then end module. So here in this particular example, if you observe, there are 2 arguments, right? There are 2 arguments which are considered. Okay, one is with respect to C is equals to A plus B, and one is with respect to X, Y and Z. We can also add up, or else we can also sum up not only with A, B, C, but also with X, Y and Z. Okay, so here remember one thing that the calling of task, okay, here we are calling of the task. The task is called out here with respect to A, B, C and also with respect to X, Y and Z. Then the task enabling arguments. Now that we have done with the calling, right? And then we will come up with the enabling. So in the enabling corresponds to XYZ, we have ABC defined, right? In the previous program, we have defined also XYZ and as well as the ABC. Then since A and B are the inputs, so X and Y will be placed in place of A and B. Okay, why? Because we have called two things, right? One is ABC and one is XYZ. The calling of task can be done with respect to ABC and XYZ as well. So because here C is the output, so because C is declared as the output and then connected with Z during the invocation. So when you're calling this particular task, you are saying that C is equals to A plus B. And then when pertaining to this argument, I can also write Z is equals to X plus Y. So C is invocated to Z, right? C is invocated to Z during the invocation and sum is automatically be passed on to the variable Z from C. So from Z, it can be passed on to C. Okay. So this is how the calling takes place. And now we'll talk about the global task. So what is this global task? Is the tasks that are declared outside all modules are called global task. Remember that the tasks which are declared outside of the module. Okay. Till now we have discussed or else we have learned something regarding the task, saying that tasks are meant inside the module. But now, global tasks are nothing but the tasks that are declared outside the module. Okay, so this is nothing but the global task and they have the global scope and can be called within any module. So here the tasks which are declared outside the module, they are called the global task and also they have the global scope that is within the module. And now we will say this task is outside all the modules. So now take display hello, right? So we have to display the hello. Then end task module, what are we doing is our task is to display the display the word hello, right? So this is our task. So how can I display is, as I said you, global task is they are declared outside the module. So here in the example, there is no way of declaring the module. Did you see any module here? No. But when you're writing your code, remember that we will start with the end module and finally end up with the end module. Start with the module and end up with the end module, right? But as we are discussing about the global task, remember that global task they declared outside the module. So here there is no need to mention the keyword module. Directly we can go with the statement saying hello and then module initial begin and our foremost task is to display the word hello, display end and then finally end module. Okay, this is how the global task can be the code for the global task can be written. And now we will see the difference between the functions and tasks. So what is the difference between the functions and tasks are? So functions is nothing but it cannot have time controlling, delay and hence executes in the same simulation time. So whereas the task in the same simulation time, in the same time the time controlling statements they executes in the same time. Whereas coming to the task, we can see that it can contain time controlling statements. So it has time controlling statements so that at different times or at different intervals of time, the task they perform their action. Whereas the functions, and when it comes to the functions, they cannot have the time controlling statement. So what happens is within the time given, within the delays, they have to perform their action. And then it cannot enable a task. So however, the functions, they cannot enable the task. They are differently, so they are totally different from each other. Okay, so they don't enable the task, whereas it can enable other tasks and functions. The advantage of this task is, as a functions, it cannot enable the task, but whereas the task, it can easily enable the other task and as well as the functions. Okay, other task and as well as the functions. And then the function should have at least one input argument and cannot have other in or output arguments. So in the functions, it should have at least only one input argument. Only one input argument the functions can have. Whereas the task can have 0 or more argument of any type. Okay, so the task can have 0 or more arguments, but it has only one argument. Okay, that is a difference. And then a function can return only a single value. So, and here it cannot return a value but can achieve the same effect using output arguments. So here the last point says that though the task it cannot give any value, but what it can does is it gives the same effect using the output argument. So it can generate the output in one or more bits by using the output arguments. But whereas the functions, we are saying that it can return only a single value. So this is just a difference between the functions and as well as the task. Then coming to the functions. So far we have discussed about the task. Tasks are mentioned, they are to be declared within the module, and global tasks are declared outside the module. Okay, this is what the difference that we have learned from the task. Coming to the functions. So functions are nothing but a Verilog function is the same as task, almost the same as task, with a very little difference. What is the difference is functions cannot drive more than one output, cannot contain delays. So in the functions, we cannot consider delays, and also we can consider the output can be formed only in one output, and they cannot contain delays. So these are the two important points to be remembered when it comes to the functions, right? So the function contains only one output, and also they cannot have any delays. Okay, they work as per not with respect to the time, whereas in the task we see that at different intervals of time different tasks can be performed, but not like the functions. Then functions are defined in module in which they are used. So obviously the functions are defined within the module so that they are used. Then it is possible to define in separate files and use compile directive include to include the function in the file which instantiate the task. So here we can give the name for this task, saying that it can compile. Okay, it can compile the directive it can include to include the function to the in the file. Okay, and then also we can instantiate the task. As I said the functions cannot have the task, but whereas a task it can have the other task and as well as the functions, but the functions they cannot have the task, and also functions cannot include time delays. As I said the functions they don't have time delays. So whatever the action they have to perform within the time limit, but not like the task. What are they do? They can have, or else they can execute at different times of at the different intervals of time, right? And then the functions cannot include timing delays like passage, negative edge, delay, which means that function should be executed in zero time delay. So the functions they have to execute whatever the job they have to perform, they have to execute within the zero time delay. Okay, but whereas a task they at 10 nanoseconds of delay, the task one can complete its function. At 20 nanoseconds of delay, the task 3 can complete its function. Okay, but whereas here the functions they cannot include time delay. Then the functions can have any number of inputs but only one output. So as we said that the task they have the different outputs based on the arguments, but whereas the functions they can consider only one output. Okay, they have any number of inputs, though they have any number of inputs, the functions, but it can give only a single output. Then the variables declared within the functions are local to that function. So whatever the variables are associated with that particular functions, they are nothing but the local. Okay, they are not just it's not the global, but they are the local variables pertaining to that function. Okay, then the order of declaration, and now coming to the order of declaration, how you are declaring your inputs, how you are declaring your outputs, right? So the order of declaration within the function defines how the variables passed to the function by the caller are used. So here the declaration plays a vital role. How you are declaring all the variables. Based on that, we can see that the function of a caller can be identified easily. Then functions can take, drive and source global variables which no local variables are used. So here the functions, they can use the global variables, but no local variables cannot be considered by the functions. Okay, then when local variables are used, what happens is basically output is assigned only at the end of the function executes. So when you are considering a local variable for the execution purpose, with respect to the task, with respect to the functions, remember that when local variables are used, what happens is output is which is assigned only at the end of the function execution. The output is assigned only at the end of the function. Okay, only at the execution of the end of the function, the output is enabled. Like that's the reason we are saying that for function, the output is carried only 1, right? Then the functions can be used for modeling combinational logic, and also they can call other functions but cannot call task. So as I said you in the reference we have discussed, right? Functions cannot call the task, but whereas a task, it can call other different tasks and also the functions. Okay, this is an important point to be remembered when you compare the functions and as well as a task. Remember that functions cannot call the task, but whereas a task, it can call other tasks and also the functions. Then here for the function we have a syntax saying that a function begins with the keyword called function. Obviously, when you are if you are beginning with the task, okay, if you perform any task, you have to start your code with the task and end your code with the end task, right? But whereas it comes to the functions, the function should begin with the keyword called function and it should end up with the keyword called end functions, and inputs are declared after the keyword function. Okay, obviously after the keyword function in the input declaration, in the port list, the input declaration need to be declared. Then, so this is a small way of representing the functions. So you can see module, simple function, and here function input declaration ABCD, and now begin my function. What are we doing is our function is to know A plus B, for adding of A plus B and subtracting C minus D, and whatever the result you are getting from R1, and then you are covering up to R1 plus R2, and then end function, end module, right? And then we will see the calling of a function. So in the previous example, based on the task, we have seen how can we call a task, right? And now we will see how can we call a function. So calling of function is nothing but the module function calling. Here, see, in the port list we are mentioning all the input and the output, right? So port list consists all the inputs and as well as the output. So my inputs are declared as inputs A, B, C, D, E, and output is declared as F, right? And what is a wire? Wire is nothing but is a physical connection. So for the physical connection I'm representing it as wire F, and then include my function dot v. So what are we doing is we are just calling the function. How can we call the function is by using the statement include my function dot v. Okay, so in the previous example pertaining to the task, right? Pertaining to the task, we have discussed like how to display a word called hello, right? So hello, how can we display a word called hello, right? So now in the calling of a function also, how can we call a function is by displaying include my function. And then finally we are assigning at the output, finally we have to declare something that my function dot v, right? So assign f is the output which is equals to my function as per the all ABCD, and E is equivalent to 0 end model. So here this particular example, okay, this particular statement here, if you observe, you can see a different operator. What is it operator? It's a replica operator. Okay, conditional operator, you can observe this is the conditional operator, right? So this is nothing but the conditional operator. Using the conditional operator, we are calling the function. Using the conditional operator, we are calling the function. Before in the previous task, we using the hello simple statement saying hello. Just to display the hello, we are writing a statement called display hello, and then finally end task, end module. But whereas the calling function, by using the conditional operator, we are assigning, okay, the output is assigned with respect to the conditional operator, and finally end module. So this is all about the task and functions in the Verilog. I hope you all understand. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.